Evaluating a definite integral. In order to do that, we're going to need some special summation formulas. Here's one for number one. This will help us add something like this, a repeated number like 2 being added 6 times. It says the answer will just be 2 times 6 or 12. If we wanted to add the integers up to say 10, this formula will give us the sum right away. And the formula will be, this is our n, so this will be 10 times 11, because we put a 10 in there, divided by 2, and so that answer will be 55. So the sum of these 10 integers is 55. This formula is going to give us the sum of the squares, so 1 squared plus 2 squared plus 3 squared plus 4 squared. And that formula goes like this: 4 times 5, and then put a 4 in here. That'll be a 9 divided by 6. And then this is going to be, this is 36 divided by 6, so that's going to be 6. And so this answer will be 30. So the sum of those integers will be 30. So these are formulas that will quickly give us an answer. Okay, we're going to use these formulas to help us find this definite integral right here, which is the area under the line from 0 to 1. Now we're doing a line. Obviously we can find the area of this triangle very easily, but eventually this format or pattern that we're going to use is going to change to a parabola, a quadratic, a quartic, and such. So let's go ahead and go through this process. First process is to define delta x. Okay, so delta x sub I, that means that's the width of each one of these rectangles, is delta x, and they're all going to be the same size, b minus a over n, which is the width of the rectangle divided by the number. And since my b is 1, my a is 0, this is going to be 1 over n. Okay, the next thing is to choose your c sub I. So we're going to start with c sub 1 first, and we're going to use right rem. So my x-coordinate will be on the right-hand side, which will be 1 over n. C sub 2 will be equal to 1 over n times 2, so twice as long. C sub 3 will be 1 over n times 3. C sub 4 will be 1 over n times 4, and so on. Okay, so I get a pattern here. C sub I will be equal to, wherever you start, and in this case we're starting at 0, a plus, and then this will be I, the term number, times delta x. That's the width. Well, we've determined the width to be 1 over n, so this is going to be a plus I times 1 over n. And we also know that our a and r term is 0, so this is going to be 0 plus I over n. So our c sub I term is in this form, and I'll just call it I over n. Okay, now we're going to actually evaluate the integral by regarding it as a limit of the summation. So the limit, as n goes to infinity, of the summation I equals 1 to n, and this stands for the height, delta x. Now in our particular case, our f of c sub I is actually 2x. So I'm going to write limit as n approaches infinity, summation I equals 1 to n, and then I'm going to write 2 c sub I. I'm putting the c sub I into the function delta x. Now I have replacements for delta x and replacements for c sub I. So I'm going to write limit as n approaches infinity of the summation I equals 1 to n. And remember that c sub I I'm calling I over n, and then delta x, remember here, is 1 over n. So I am going to rewrite this problem, and I'm going to take everything out that's not an I, so this will be the limit as n approaches infinity, and I'm going to take 2 over n squared summation I equals 1 to n of I. Now, we just talked about that formula, and we know that we have a formula that can replace that. 2 over n. And that formula is n plus 1 times n over 2. I am now going to do some reducing, and I can see that this should have been a square here. So now this is going to be the limit as n approaches infinity of n plus 1 over n, and that answer will be 1. So I have found that the limit is equal to 1. In other words, the summation right here is going to be equal to 1. Okay, let's go ahead and do the problem again, but this time let's go from negative 2 to 1. Now, when you do negative 2 to 1, again, we're going to define our delta. Now, you notice that our interval widths are going to be a little different than they were before. We are now going to choose our c sub I. So we are starting from negative 2 instead of 0. So the general term will look like this. And then we're going to want to write the definite integral and evaluate. So we're going to, again, take the limit, and here's our f of x, and here's our f of x in 2 times c sub I. I have a replacement for c sub I. I have a replacement for delta x. And I go ahead and I pull out everything that doesn't have an I in it, a factor, so 6 over n can be pulled out. And then the summation of a sum is the sum of summations, so I take the summation of each. Now this is rule 1. I'm going to times it by negative 2 times n, which is going to be right here. And then I have this summation of I, which I had just a few minutes ago here. Do some simplifying. I'm going to get this expression, and then I'm going to get my answer, which is negative 3. Okay, now we're going to do it by evaluating another integral. Now notice that this is going to be a quadratic, but I start the same. I have to define delta x, which is 3 over n. I've got to choose my c sub I. Since I'm starting at 0, this is going to be 0, and this will be 3I over n. And now I'm going to write my definite integral. Here's the standard form. Here's my function, which is squaring. And then when I substitute, I get here. Now at this point, I'd like you to stop the screencast and see if you can finish. And here's what it would look like after you finish. I'm going to be expanding this by pulling out the factor 27 over n cubed, and I have the I squared in there. And then I'm going to substitute the summation formula, do my limit, and then find that my answer is 9. For your exercises, I want you to evaluate these two definite integrals. Now, they have the same type of form, a little change, and if you'll follow the examples, I'm sure you'll be very successful.